Honestly, I could do that all day. No problem. Hey everyone, and welcome to Wintergatan Wednesdays. There has been a lot of progress on the Marble Machine X lately, and today I want to show you how the muting system works, along with like 25 other new features. Here I'm just demonstrating the treadle pedal just to show you how it works and deactivating it. It's a safety feature, so the pedal can't crush my foot. Actually, a suggestion from a YouTube comment. So check the black plate now, the programming plate passing the registrators. There, you saw the little movement, but no sound, because the vibraphone is muted. And here I'm unmuting the vibraphone. So the next time the black panel passes the registrators, the channel is activated. Listen up. Last week I had Marius, Alex, Tomas and Hannes here for an intensive week of building, and I've been preparing that week for a long time, and we could assemble a lot of parts. So these are all some of the new improvements that we've been making. I realized that the anti-vibration feet had too soft rubber, so I made some temporary MDF rings and bypassed the rubber of the feet, and that stabilized the Marble Machine X immensely. It's really stable now. We assembled this treadle pedal, and there was someone writing in the YouTube comments that if my foot got caught underneath the pedal, it would crush the foot with the entire weight of the Marble Machine X. So I redesigned it and made a pivot point in the foot, so it's stiff in the downwards direction, but it flexes in the upwards direction. And I'm getting better and better at TIG welding, but those TIG welds are my absolutely most ugly welds ever. So we cut these acrylic protection plates and put them into the hand crank wheel. Marius cut those on the CNC machine. And these prevent my fingers from getting stuck between the spokes of the crank wheel and the piston from the treadle pedal. On the crankshaft next to the crank wheel is the crankshaft flywheel pulley. Alex assembled this, and this one drives the flat belt down to the flywheel, and it has a 3 times bigger diameter than the pulley that sits on the flywheel shaft, which will increase the moment of inertia stored in the flywheel. And here is the flywheel. Later, we will add a belt tensioning clutch system, so we can also let the flywheel loose when we want to brake the machine fast. The flywheel is super strong. Next improvement is that we depthed all the gears of the whole Marble Machine X. And I think I had made them too tight, because when I cut the gears for the first Marble Machine, I cut them by hand on the bandsaw. And obviously I had a lot of slop. So now when I could make gears on the CNC machine, I tried to get minimal to no slop. And when Marius, Alex and Tomas felt the gears, all of them were of the opinion that I had too little slack between the gear teeth. So we recut some gears with smaller radiuses and inserted a little more slack, and all the gears are now running so much smoother. Next, we changed the disc magnets in the marble ring lifts. We now made them half the thickness, from 4mm to 2mm. We also changed the things that hold the ring gear laterally. Marius redesigned this and came up with an idea for using 4mm bearings. So it's like a really tiny bearing in there. You can't see it because it's in the shadow, and the ring gear runs much more silent and smooth. And this is another feature that we longed to assemble for a long time. It's the V-belt that will rotate the marble demagnetizer. And this was Tomas' project in the beginning of the week. He machined this little aluminium pulley, and he also designed it in CAD, and he also machined the corresponding pulley that is on the programming wheel shaft. I think this is an awesome little hidden detail just sitting behind the planet gears. There's so much mechanical movement going on in that section. I love it. Staying in that section, we zoom out to the fish stair and conveyor belt pistons. This is another heroic effort by Tomas, because he had to shorten the main shaft by hand. So he was hand filing the main shaft and made this fit as good as you can see here on the picture. So these two pistons will drive the conveyor belt that will lift the marbles and also the fish stair that will lift the marbles. So far we didn't attach it to the linear bearings, so we just put two springs here to demonstrate the rhythm. And speaking about the rhythm of the pistons, they go in perfect half time in sync with the music. So when the crank moves 2 rotations, the pistons move 1. So it will be super cool effect of both the conveyor belt and the fish stair, where it will lift all the marbles in time with the music. Inside the marble divider, there's a whole lot of mechanical voodoo going on that you can't see. If you watch carefully here, you can see that the marble divider is not letting the marble queue down until the pivot thing has returned to its original position. That's because of the marble lock underneath, a little aluminium bracket that keeps the second marble locked up. Let me show you. So check what happens here. When I return the fork, the second marble charges. I'm dropping a marble and I'm waiting. I'm playing really slow tempo here, and not until I release back, the second marble comes charging again. Isn't that some voodoo? This feature was really missed from the original marble machine, which made it impossible to play music in slow tempos because the marbles were just going everywhere. Here's the same thing showed from a different angle. I'm releasing a marble, and not until I let the fork go down, the second marble charges. I mounted a gear with a 20mm hole for the marble to pass through before hitting the vibraphone plate. Because the marble is 16mm, it only has 2mm on each side if it's going to hit that opening. So this is just to show you that the dropping mechanism is quite precise. And here is the second release. And here I'm showing you again how the marble lock holds the second marble until the fork is closed. The second release is very adjustable. You can adjust the spring tension, and you can finally adjust the position of the fork and the position of the whole thing. It's a test batch, and I'm gonna improve the design before we make all 38 of these. So we finally made our way through to the subject of today's video, the muting levers, with the bistable mechanism suggested by this old Tony. They are a little bit corny right now because I made some temporary springs from TIG filler rod, but once we have the correct springs, this will just work like a charm. Here you have to keep an eye out in this area. This is where we're engaging and disengaging the mechanical movements by the help of the muting levers. So we're breaking the mechanical chain from the registrators to the releases, and therefore muting and activating the instruments. So here, the programming pins are passing the muted vibraphone channel. Keep an eye for this tiny motion over there. There's no connection because we disconnected here. And now I'm activating the vibraphone. And I'm letting the programming pins pass again. Now you can see that the small little hooks have engaged, and we will hopefully hear a sound. Here's the same demonstration from the opposite angle. You can see how the programming pins are passing and activating the registrator, but since the hooks are disconnected, nothing will sound. So I'm activating the vibraphone with the muting lever, and here we go again. And yes, I'm really stoked about this. And I wanted to show you some building process in this video as well. So let's assemble 3J6000. This is the last part of the muting lever system. We did film a lot during the intensive week, but all that footage is being processed. So this is some parts I filmed after the team had left. Here I'm working with parts cut by Seth from Roys Sheds Australia. He has a video showing how he made these parts. I'll leave a link in the description. And what we noticed with these DXF cut parts is that there's a lot of post-processing. And sometimes with the plasma, not so much with the laser and even less with water cutting, the pieces get a little bit hardened. So drilling and tapping these pieces, for me as an inexperienced metal worker, it's quite a pain. It takes so much time to work with metal. I'm really a plywood person, and I'm slowly getting accustomed to how much work it is to actually treat metal. And I don't really have a lot of big tools for working with metal, so I'm going on with a lot of hand tools, and it's taking a lot of time to assemble these metal sub-assemblies. So anyway, here you can see my former pipe-in-pipe system. It's this holder there, and I'm going to take it off so you can see the pipes that are underneath. So there you can see the different diameters: 30, 26, 22, 18, 12 and 8 millimeter, I think. And these levers corresponds to those diameters, as you can see. So there's 6 levers for the 6 instrument groups: vibraphone, kick, snare, hi-hat, sizzle cymbal, and last but not least, bass. So the levers goes into these holders, and I had to wiggle them a little bit to get them into place. And here came a really scary part of the assembly, because I needed to cut off a whole corner of the beloved steel frame, because I redesigned this after ordering the frame. It was actually when I was discussing the bistable mechanism with this old Tony that I redesigned this whole part. So here I'm just chopping off a whole corner of the frame, and I'm replacing it with this new design. So I'm welding it in place here. This was a little bit scary because I was scared of messing up the precision of the frame. So I'm welding from these awkward positions, and I've really learned that TIG welding with good working position is difficult but doable. TIG welding with bad working position is really difficult. And here's another trick I learned from Marius, to really clean the parts before welding them. So I clean them with a steel brush, and then I also clean them with some petrol to remove all the oils and greases from the metal, and that leaves a little shinier weld and a little better looking weld in general. I think you should always clean your parts before TIG welding. I'm just not so thorough always. That's the corner for the new frame, and I think it looks okay. I think it's in the correct position. So these are the pivot points. They also needed a slot for the links to be able to move inside, and I don't have good machines. I had to cut this with an angle grinder. It worked out pretty good actually. And here I'm sanding the inside radius for the bearings. I'm using this Loctite 638 bearing glue. And according to Alex from the team, this glue is really strong enough. I had some bearings with a red color and I just painted them black because I don't want any red in the color scheme of the Marble Machine X. So all the bearings are glued in, and the fit of the bearings were quite loose, so I'm still a little bit doubting about this bearing glue, but time will tell. And I'm making this shaft here from a bad material, so it was very oversized. And I don't have a lathe, so this is my way of laying down the shaft to a better sliding fit for the bearings. And this took a lot of time, but in the end I got the bearing to slide quite snugly over the entire length of the shaft. Things like this takes a lot of time. It's strange, but the Marble Machine X now has 8,000 parts. And here you can see me spending maybe 1 hour on one of the parts. I'm filing a little flat spot for the end to sit in there. And yeah, basically because of inexperience, it takes a lot of time, but also every part takes a lot of time. I saw Marius, Tomas and Alex working when they were here during the intensive weekend. I reckon all three of them are super efficient. They're very efficient when they work. I got really inspired. They stay focused on the task and they push the task forward. But I also realized that assembling these sub-assemblies also took a lot of time for them because of all the post-processing of the metal parts. I always thought that I was really slow, but after seeing three very efficient workers also needing a full day each to assemble one sub-assembly, I realized that it's not only me being slow, it's actually a lot of work involved in these pieces. So that was a little bit comforting. Here I'm making temporary springs from TIG filler rods. I'm gonna order real springs, but I didn't have anyone at home, so I just made these temporary springs so I could try out the bistable mechanism. So I welded this shaft onto the machine and drilled and tapped the end of it, and on this shaft goes these spring links that are the pivot points for the springs. And these square washers that I'm putting on right now, they are also the spring tensioning system. So if the spring is a little bit too loose, we can just put a lot of these washers. You can see that I stacked 4 or 5 washers in this example. The more washers I stack onto the spring link, the more tension the spring will have, the compression spring. And here I laid out a template IRL with the measurements from CAD on how the muting levers would be. So I sanded a bevel in these rods to make it easier to tap the outside thread. Then I could heat up the point where I wanted the rod to bend, just to help the rod in bending. I didn't heat it up a lot, but I think this softens up the atoms of the metal and creates a better bend. I could probably have bent it completely cold, but I think heating it up is not a bad idea. So I'm using the mallet from Marcus Wunderlich, and I'm using that a lot. It's really nice. I thought it was really big when I got it, but it's proved to be super practical. So thanks again, Marcus, for the mallet. Probably the whole comment field is super excited that I finally have a wooden mallet, because I got so much slack for using a metal hammer before. These will later receive a super good looking round black ball end, you know, the machine kind of handles that has a thread inside. The outside thread is M8, so I think the ball will be 30mm in diameter, so that will look awesome. They're gonna be the aesthetics for all the levers of the whole machine, because these are not the only levers of the Marble Machine X. There will be a lot of levers on other positions on the machine, and I'm going to stick with this 8mm round bar and a black handle on top. So the parts I'm working on here is quite eclectic, or for a lack of a better word. This one that I'm welding on here is a metal bar that will be mic'd with a contact microphone that the machine handles will swish over. This is all gonna come very clear to you later. But then I'm adding here another stop, and that's also gonna be mic'd with an individual contact microphone. And these 3 metal bars will let me handle the stop sound of the muting levers of the Marble Machine X perfectly. Shkoof, shkoof, like that. That's going to be awesome. So here's another example why designing in CAD helps so much. The angles that these muting levers are pivoting in are very precise, and that's calculated and designed in CAD. So the angles of the levers are 54 degrees, and the angles of these small levers is exactly 17 degrees. And by measuring the different lengths of the links and the pivot points from their different pivot centers, I can achieve this mechanical advantage and have exactly 54 degrees on the head and 17 degrees on the connecting hooks. I'm very happy that all that worked out perfectly. Okay, that's it for this week. Thanks to Marius, Alex, Tomas, Hannes and Chris for keeping me company last week and making so much progress on the Marble Machine X. And thanks to you for watching. It's autumn here and my brain works again I don't know, I don't think so well in heat. My brain is like wired to work in Scandinavian conditions, and now when the nights go down to at least 15 degrees Celsius, it's like everything comes loose, and yeah, it's nicer to work. It's wonderful. So I'm gonna keep on pushing, and I'm gonna keep on making videos to let you all know what is happening. Okay, well, see you on the next Wintergatan Wednesday.